of heat transfer, mass transfer equipment, designing, fabrication, erection, commission. In this company, we have 3 patented. One today I am representing it. Two-way feeding and condensate sealing system to increase individual effect overall heat transfer coefficient. To increase individual overall heat transfer coefficient means we will increase water evaporation capacity, solid concentration, and steam economy without addition of new body or surface condenser. It will be a patented process of management engineering, as I already explained. Tomorrow I will present another patent process, that is to leach out non-process element from the agro raw materials. And by last in the third day, I will give a presentation of state-of-art vertical light kiln, that is to produce low silica calcium oxide with the lowest possible cost. It will be some transformation technology. So we are here to discuss first two-way feeding and condensate sealing. Let me begin this. So as we all know, recovery is considered as the heart of any paper mill. If the recovery is running good, overall profitability you can see. If you see in the general term, if the evaporators is running good, steam generation from the recovery boiler side is high. In India, an average paper industry is producing 30% steam contribution from the recovery boiler and the 70% approximately from the powerhouse. Those has achieved a good benchmark. They are getting approximately 55 to 60% steam generation from the recovery boiler and the remaining from the powerhouse side. So recovery is a very, very vital important department, and it has to be given time and investment if little bit required. Definitely sensibly. So because I don't know how many people are from the recovery side, so I want to explain this process in very simple way. This is the general working of the MMEs. If you are applying the 10 ton of the steam in the first effect, where vapor generation will be 9 ton, taking the steam economy as a 0.9. And these are the steam economy factors: 0.9 for the first effect, and 0.9 for the second effect, 0.95 for the third effect, because as the vacuum increase, there is an increase in the steam economy. In the last effect, if you will see, the steam economy factor is 1.15. It is not only due to the vacuum as well as the vapor generated by the PCFT, SCFT and the WBL plastics. This is the, if you see, if we discuss how to gauge the efficiency and the capacity of any evaporator. Some of the designers are utilizing heat transfer area as a 128 meter square per ton of water evaporation capacity. You can calculate. There are other designers, those are considering heat transfer area 115 meter square per ton of water evaporation. And they are very good designers. Those are utilizing only 75 meter square heat transfer area per ton of water evaporation. So how we can say that this evaporator plant is running on 100% capacity? Designers have their own designs, and they have sometimes lot of cushions. They will give you the guarantee. For the example, they have given the guarantee of that 100 ton water evaporation is possible. Do you think water evaporation is only 100 ton is possible? It may be possible he has taken 100% cushion. It may be possible that he has 50% cushion. Means water evaporation is 150 is possible. So in general term, I would like to say, if your steaming body means first figure, if the overall heat transfer coefficient is 2000, then take it 100% capacity. This is the maximum steam you can charge. Even more than that, you can charge. I will give you the backup. If you would like to know, I will give you that. So, if your first effect overall heat transfer is coefficient is only 1000, then your plant is just running just at 50% capacity. So, if you see the first effect as a bundle of the body effect, first body as a bundle of bodies, overall heat transfer coefficient usually are in the range of 400 to 600, it is near about. I have seen the many evaporator data I have collected from there. So overall heat transfer coefficient running is only 1500, 1600 watt per meter square degree centigrade. So you can say, think that how much cushion is there. We are revealing those capabilities of the industry. So industry, I don't know, it seems that industry has already 1.5 times the capacity, but it is not known to them. We are unveiling those facts. So approximately 1000 watt per meter square degree centigrade means you can charge steam 20 kg per meter square per hour. So this is the way. This is the general data collection. If you are running a plant, evaporation plant with single effect, steam congestion will be 1.1 ton per ton of water evaporation. So if you are using 2 effect plant, it will be 0.55, and if you are using 7 effect, steam consumption will be 0.16 ton per ton of water evaporation. And if it is 8 effect plant, steam consumption per ton of water evaporation will be 0.140, means 140 kg per ton of water evaporation. In our patented process, we can assure a steam economy of 7.3 ton per ton of water evaporation. So what is this system? How does how it works? What is the condensate sealing means actually? This is the one part. Suppose this is the finisher part, and this is the heat exchanger, or you can say this is the calandria part. Condensate is coming to the condensate part, and this is the vent line in the air. Do you think this system is providing any sealing? It is just what you can do. You can control the level of this pot, and it usually see the line of the condensate usually is connected at the 100% position of the impulse line. If the control system LTs has 2 points, 0 and 100, you will see the line is connected at the 100% level. So how it is providing sealing? It is if you see, this is the open area. Not only the condensate will come, steam will also come in this area, and steam will get vented. If you see from the port to port, the same system is there in the design, in most of the design. So ultimately what is happening? When this type of the system is coming, vapor are short circuited to the next body. So as per this patent process, salt cake, ESTS, all is to be dissolved in the WL instead of SPL, and then feeding these two either in the first effect, second effect, or third effect. Reason being, if you dissolve this salt, usually WL has Na2SO4 concentration 3 to 4 GPL. If you add directly this salt, it is getting dissolved in the lower solubility region. So salt is completely get dissolved in the WL instead of the HPL, because the liquor which has already achieved 75% solid concentration, if you see the concentration of the Na2SO4, it will be approximately 35%. 35% taking the mole fractions of the Na2SO4. So you are dissolving Na2SO4 in the liquor where it has already achieved its crystallization zone. So it is not getting completely dissolved. Better it is to dissolve in the WBL. And the WBL temperature are usually 90 degree. So whenever you are mixing the salt caking in HPL, which has a temperature of 135, it is getting dropped. Then you are feeding again to the finisher. So most of the steam is getting consumed in increasing the temperature of that particular liquor to the boiling point. So heat transfer in that means you are not achieving that capacity what you wanted to. Suppose I am taking this presentation as a discussion point of view. Your points is also solicited. So if you see, if you have installed new evaporation plant, so it will cost approximately 30 to 35 lakh rupee per ton of water evaporation capacity, including all from production to production. So by this process, you will be able to reach water evaporation capacity approximately 1.5 times. You can estimate how much investment you will save, because if there is an investment, there is an interest cost, and there if it is an investment, there is a depreciation also. So come to the point. So for the example, better I move to the main slide so that you could understand how this process works. WBL comes from the bulk mill, is collected in the WBL tank number A. Overflow of this tank comes to WBL tank number B. From WBL tank, the liquor bifurcated in two pipelines. One is line B, one is the line A. 70% of the total liquor feed is feed in the backward mode, means this flash tank number, if it is a feed flash tank number 1, 2, 3. In WBL is fed to the feed flash tank number 3. Its flashing is used in 60 pack calendar year. Then liquor moves to the feed flash tank number 4. Its flash is used in the 70 pack calendar year. Then liquor moves into the last feed flash tank, which is the number 5. Its vapor is get condensed in the surface condenser. Then liquor moves in the 70 pack and the move on. 30% of the total liquor is fed in the wash body. Suppose C is the wash body. In this particular body, liquor, it is cut from the liquor side, but vapor and steam side is still open. And when the liquor, WBL or any liquor which have viscosity approximately 5 to 10 cp, you can charge steam as high as 25 kg per meter square per hour. So after, as you will charge the steam, part of the liquor will get evaporated. Product of this will move to the wash body of second effect. Suppose in right now our wash body is second B. This liquor will move to the B. After flashing, it will mix into the finally to this. So what happens? One body is always remain in the wash mode in the first effect. One body always remain in the wash mode in second effect. Similarly, if you have concentrator as a first effect and total you have a plant of 8th effect, you can achieve 7.3 steam economy as well as high water evaporation capacity. High water evaporation capacity, high solids and high steam economy. So you have always a body in wash mode as well as cleaned. So also if you see, when the liquor moves from the second to third effect, the volume of the liquor decreases and its viscosity increases very high. So it's quite natural that when the viscosity will increase, its frictional losses will also increase. Because whole the liquor, if you suppose first effect have 4 bodies and you are feeding that HPL or 60% solids liquor in the first effect, so it will scale up the whole finisher body, though it is not required, because usually if you see other designer used to charge only 5 kg per meter square per hour steam. So if you are not charging the steam in the enough steam in the body, how can you get the heat transfer coefficient? So if the liquor has viscosity up to 5 cp, you can get as high overall heat transfer as 5000 watt per meter square degree centigrade. And when the viscosity has 400 cp or 1 cp, overall heat transfer coefficient must come at least 2000. This was the whole presentation in the simple. We have already implemented this system in the Sirpur paper mill unit. It is right now it is owned by the JK paper mill. So they had a plant, polyvinyl 7 plant, but they were unable to utilize their feed flash vessel due to some design issues. And in the first attempt we have utilized their feed flash vessel, because as soon as they were opening the valve, it was getting contaminated. Right now the same type of system we are implementing for the Star paper mill also. So we have calculated this one. Earlier design in 78, we have calculated for this data for a random paper mill for the calculations only. Rate will be 78, after modification will be 110. Mass flow rate will be 84 earlier. After the modification, it has some error, 104, it will be more, because the density is 1.08. So these are some calculations. This is the wetting degree, existing wetting degree. And here we have not mentioned the wetting degree. Definitely the client person who is interested will reveal all the data, because it is a patent process, you know. So some of the information we cannot disclose. Okay, sir. This is specific water evaporation before and after. This is the overall heat transfer coefficients before and after. So what will the impressions? There will be increase in the steam economy of the evaporator. Solid concentration will increase. Higher SPL solid will result in high steam generation in the recovery boiler. Water evaporation with capacity will increase. If the solid concentration will increase, boiler thermal efficiency will also increase. It is just like आम के आम गुठलियों के तरह.
आपने वहाँ देखे में क्या अचीव किया है?
I think this would be enough. If you have any ambiguity or doubt, you can ask. I can rotate this presentation again.